Different forms of differential equations require specific methods in solving them. Learn the different types of first-order ordinary differential equations and the methods to solve them here in Engineering Math 5. Let's review what a first-order differential equation looks like. In the case of having dy all over dx is equal to the functions of both x and y, with dy all over dx on the first level makes it categorized as order 1. This is standard form, but most often we can also see it written as y prime is equal to f of x and y. There are differential equations with the form of dy all over dx is equal to the functions of both x and y. Note that the function of x and the function of y can be separated, thus the name of separable differential equations. An example we can associate with this type of DE is dy all over dx is equal to 3x y squared, where 3 is a constant, then x and y squared can be solved separately by integration. Linear first-order differential equations are with the standard form dy all over dx plus p function of x times y is equal to another function of x. It is not possible to separate the two variables at this point. For example, dy all over dx minus 3xy is equal to 2 times e raised to x. But we can still solve this dE by using an integrating factor given as mu of x, which is equal to e raised to the integrand of p function of x dx. In the case of nonlinear first-order differential equations, these are those functions with exponents more than 1. Analyze the standard form given as dy all over dx is equal to the functions of x and y. In this case, x and y are either added or subtracted, and they are not separable. To be able to solve this type of DE, substitution method is incorporated, where we allow a variable v to be equal to the function, and extracting y we get v less x. And then taking the derivative of both sides, we have dy all over dx is equal to the derivative of v with respect to x minus 1. For homogeneous differential equations, the standard format to look for is dy all over dx is equal to the function of y all over x. For example, we can arrange the function dy all over dx is equal to x squared plus y squared all divided by x times y to make it in the standard form of y all over x, and further solve it by using substitution method. And again, where v is equated this time to y all over x. Another type of first-order differential equation is the exact equation. The standard format shows function of x and y, where it is also a function of x, is equal to the constant c. This can be translated as m function of x and y times dy, and nth function of x and y times dx is equal to 0, where m is taken as the partial derivative of f with respect to y, and n is the partial derivative of f with respect to x, and m and n should be equal. The last type is the reducible second-order equation. These are those with the form of function of x, y, y prime, y double prime. And since there is y double prime, it is noted that it is already in the second order. However, we can reduce this equation to the first order by substitution method, whereby we replace y prime with v, and y double prime is now v prime, which would mean it is just the first order of v. The different types of differential equation follow different sets of solution methods. The first method which can be used is separation. In cases of separable differential equations with the form dy all over dx is equal to the function of x times the g function of y, where f of x can be separated from g of y. So by separation, first step is to actually separate them and arrange in such a case that y terms will be with dy and x terms are with dx. Then integrate both sides. The second method is homogeneous method with the form dy all over dx is equal to the function of y all over x. Before solving, one has to check if the equation is indeed homogeneous, and that is done by substituting the variables with a constant and same variables. So in the case of function of x and y, one will use function of k times x and k times y. After proving that the equation is homogeneous, we can substitute a variable to cover for both original variables, say v. Then work with product rule to simplify the equation. Another method used for certain types of differential equations is using an integrating factor. This method is used for differential equations in the form of dy all over dx plus p function of x times y is equal to the q function of x. So first, identify p of x. And upon having a certain relationship for p of x, plug this into the integrating factor mu of x with the formula e raised to the integrand of p of x times dx. This modified integrating factor is then multiplied in the function, where the left side will have the format derivative of mu of x times y with respect to x. The last method is exact DE, which is used for the differential equations with the format m function of x and y times dx plus n function of x and y times dy is equal to 0. The format is to be strictly followed in order to clearly set m and n, and then check if both m and n are equal by taking the partial derivatives of the sides, after which integrate one of them to have the solution.